Folks, let's take out your notebook. Take out your Unit 6 packet. Open it up to page 2, where we were yesterday. And then your pencil, please. Okay, thank you. It's from 10 minutes ago. There was no teacher with you last period? All right. So, ladies and gentlemen, as I've said, you should have out your notebook. You should have out your Unit 6 packet. Open it up to page 2, please, where we left off yesterday. And your pencil. We have a very short class today in terms of what I have planned to do with you, which is to finish the practice questions that are in our packet for Newton's first law. And then the rest of your time will be to either work on makeup work because you haven't completed work that you owe me, or to work on the assignment due Monday, which is page 3 in your packet. Okay, so if you'd like to make a note right now, page 3 in your packet is the one that you need to have done for Monday. I expect you'll be able to get that done today, unless you are making up other work for me that you are behind on that needs to get caught up. Okay. In addition to getting that done, you should, of course, study a little bit. So that way, when you get the quiz on Monday, you're not like, what? Even though you've already done the written assignment, I don't want you forgetting it. Okay. All right. So let's continue. Yesterday, we got through question 6 on page 2. So now we're going to start with question 7 on page 2. And I've asked you to take out your notebook so that way if you need to look up anything related to Newton's first law, you can. Okay, so let's look at question number 7. 2 bricks are resting on the edge of a lab table. Shirley Sheshort stands on her toes and spots the 2 bricks. Why does she have to stand on her toes to spot the bricks? Because she's short. That's right. Okay, now she acquires an intense desire to know which of the 2 bricks are most massive. Since Shirley is vertically challenged, she is unable to reach high enough to lift the bricks. She can, however, reach high enough to give the bricks a push. Discuss how the process of pushing the bricks allows Shirley to determine which of the 2 bricks is most massive. What differences will Shirley observe, and how can that observation lead to the necessary conclusion as to which brick is most massive? So what do you think? Right? That's right. Perfect. Newton's first law, remember, talks about inertia, resistance to change in motion. So the brick, and here we want to know which one is more massive. So instead of talking about the one that's less massive, what would you notice about the one that's more massive? More inertia, and therefore, right? There you go. So the brick that is more massive has more inertia and requires more force to change its motion. And the change in motion that we'd be talking about is going from rest to moving. Okay, it's going to start off at rest and then it's going to move. So if you want to put it into motion, you're going to have to push it harder because it has more inertia and therefore more resistance to that change, more mass. Okay, let's go to number 8. The Colony High physics teachers are taking some time off for a little putt-putt golf. The 15th hole at the hole-in-one putt-putt golf course has a large metal rim, which putters must use to guide their ball toward the hole. This Famoso guides a golf ball around this metal rim. So it's going to start here and continue around until it gets here. And when the ball leaves the rim here at this point, which way is the golf ball going to go? Is it going to go toward 1, 2, or 3? Now, let me just kind of indicate what you're looking at. Let's say this is the rim. This is not made out of metal, but let's say it is. That's what we have. It's flat, parallel to the ground. The ball, as you can see on that picture, as we told you, is going to start here. It's going to go around, and when it gets here and it leaves this, what is it going to do? Jacob, what do you think? Straight. So which point is that in the diagram? Can you tell me why it would go straight? You are correct. It should go towards point 2, but why? Talk about it in terms of Newton's first law, since this is part of our Newton's first law assignment. Let's look back in your notes. What does Newton's first law tell us about something that's moving? Be more specific. How is it going to keep moving? But how is it going to move when there are no unbalanced forces? Again, look back in your notes. We should have this written down from yesterday's class. When something is in motion and the forces are not unbalanced, what did we write down about how it will move? So if at this point we know it's going to the right, which way does it have to keep going? To the right. That's what Newton's first law says. When it leaves this, is there a force acting on it anymore? Up until that point, the rim is pushing it. But once it leaves the rim, there isn't an unbalanced force. So it must continue moving at a constant speed in a straight line. It cannot accelerate. That's what Newton's first law says. So the ball will move towards point 2 because when there isn't an unbalanced force, if you are moving, you will, or if it is moving, because if it is moving, I'm trying to use the proper grammar here, it will keep moving at a constant speed in a straight line. And that is point 2. That's what we're talking about. That is Newton's first law. You should be able to explain it all the way. You can't just say an object in motion will continue moving. You have to tell me how it will keep moving. Okay, let's look at how that works. Let's verify what we just said. Here's that rim. Watch. Here we are. Did you see that? Do it again. It did go straight. It didn't curve anymore. So once it leaves, there's no unbalanced force, so it will keep moving at a constant straight speed in a straight line. And that is discussed in Newton's first law. That's Newton's first law. All right, number 9. We have a 4-kilogram object moving across friction-free surface with a constant velocity of 2 meters per second. Which one of the following horizontal forces is necessary to maintain that state of motion? When we talk about maintaining that state of motion, that means there is no acceleration. How much force does Newton's first law say you need if you do not want to accelerate? What does Newton's first law say? How much force is needed? Do you need 0 newtons of force, half a newton of force, 2 newtons of force, 8 newtons of force, or it depends on how fast you're going? What does Newton's first law say? Jackson, what do you think? Yeah, 0. When we say there isn't an unbalanced force, that means there's 0 newtons of force. This is telling us that the F net we discussed yesterday is 0 newtons. Remember, F net is referring to the amount of unbalanced force. How much force is unbalanced? There isn't any. Everything has to balance out in the first law if you are not going to accelerate. That's what the first law states. Again, this is Newton's first law, which is explaining and describing that. Okay, any questions for me? Dan? So, because there is another force opposing gravity. So if I have something on a surface, the table is also pushing up. So the force of the table pushing up and the force of gravity pulling it down balance. So there isn't an unbalanced force acting. Okay. That's going to be part of our presentation when we go into section D, is talking about more about the balance versus the imbalance. Okay, so as I mentioned earlier today, if you are 100% caught up with work for me, then you're going to work on this page, which is going to be due on Monday, which happens to be December 1st. Okay, so we are done with our November class days. This is due our next class, page 3 only, but you also need to study. If you owe me anything, like a lab or a quiz or anything like that, or, well, I don't know what else there would be. A test, you all took your test yesterday. Then you're all set to go. You can just work right on this. And then if you want to do any lab corrections, you can do lab corrections. Or you can then work on something for another class. But until you are caught up with me, you're not even working on the homework. That should be lower priority than getting caught up with the work that you owe. Okay? Questions? All right, so go ahead and get to work on that. You've got quite a bit of time here.